Hello students, today we are going to learn topic states of matter. This topic number 10 in 11th chemistry textbook copy, and that name is the states of matter, that is gaseous and liquid states. Now in this topic we have to study especially the gaseous and liquid states of that particular substances. Do you know that the matter can be divided in three states? Okay, so solid, liquid, gas. Now in three substances, how the intermolecular forces are present, very well known. Okay, in solid, intermolecular forces are very strong. In liquid substances, intermolecular forces less strong, and in gaseous state, that these forces are very weak forces. Okay. Now the next point is that the types of intermolecular forces, or this is also types of intermolecular interaction. Now the first, they have given here 5 types. The intermolecular forces classified in this way. First one is the dipole-dipole interaction. Second one is the ion-dipole interaction. The third one is the dipole-induced dipole interaction. Fourth one, hydrogen bonding, and the fifth one is the London dispersion forces. Okay. Now we will see this first dipole-dipole interaction. Now in this case, dipole-dipole interaction, how this is actually here, the way they have given that particular study in textbook copy. Now, for example, this is that HCl molecule. Okay. Now, this HCl molecule you have picks up. So, in these two atoms, which type of bond is present generally? Covalent bond. One is here delta plus, and this one is here delta minus. You know that partial charges on hydrogen positive, and then Cl negative charge. Means here such a molecule can show the dipole-dipole interaction. You write here another way of that, like this particular diagram. This is HCl, another molecule HCl. The way of this hydrogen, this is chlorine. Here hydrogen, this is chlorine. Delta plus, delta minus, delta plus, and this is delta minus. Now here that particular attractive force. So dipole-dipole interaction is nothing but it is the electrostatic force of attraction between these two molecules. Okay, so that's why this such interactions develop here. Now these molecules are generally polar molecular. Here polar covalent molecule. Do you know that polar covalent molecules? Okay. Now these molecules also have certain dipole moment value. Okay, they have dipole moment. That's why more dipole moment, they can show more dipole-dipole interaction. This is the another one. Now the dipole interaction, here dipole moment is stronger. So then higher dipole-dipole interaction, and then again it leads to that effect on that the boiling point of that substances. Okay, so boiling point generally increases as the increasing dipole moment, as the increase the dipole-dipole interaction. For example, the ether having that 248 Kelvin that boiling point, but methyl cyanide having that the boiling point is 365 Kelvin. So this is first. Now we will see second type, ion dipole interaction. In ion dipole interaction, the name itself what having certain meaning indicates some meaning. Ion may be cation or anion, and dipole that another molecule having two poles, and between that interaction nothing but this type. Okay. Now this again ion dipole interaction is nothing but again it is a result of that. It is created due to the electrostatic force of attraction between ion. Ion may be cation or anion, and partial charges on polar molecule. Okay. Now the strength of this interaction depends upon what? Charge and the size of ion. As the charge increases and as the size decreases, then this type of interaction, type of forces goes on increasing. For example, look at this Na plus, magnesium 2 plus and Na3 plus. charge increases, but size of this cation decreases. Therefore, this type of interaction is increases. Now, this ion-dipole interaction is important, especially that aqueous solutions of salts. For example, that sodium chloride will dissolve in water. Okay, so that time each Na plus ion is surrounded by the 6 water molecules. So, surrounding of this cation by water molecules with oppositely charged. You understand? That is called as hydration. This is the hydration process. So, way of the interaction between this cation and that water molecules is the way we can see here. How this is the way of that sodium Na plus and this oxygen, the interaction attractive force is there. Now, look this dipole-induced dipole interaction. Okay. Now, this is third type of that interaction. What is again that word indication? Dipole. One having that the two poles and the another one induced dipole means another one is not polar molecule. Okay. Not having also that dipole moment also. Still, in these substances or in these molecules develop that particular polarity, and that's why word is that induced dipole. Okay. Now, this is again that the electrostatic force of attraction between these that particular two molecules. But how the way here, how that force is developed, this is the example. For example, you see here this one molecule is polar and another one is the non-polar. And in between that particular electrostatic force of attraction is created. Now here polar molecule is ammonia. You know that polar molecule, for example, ammonia, water is also. The ammonia molecule having that the dipole moment, certain dipole moment having value. Now this is another non-polar molecule having that the no dipole moment, zero dipole moment value, and in this case the particular attractive force interaction is developed. How this is that nitrogen and that is particular carbon. Now here this ammonia molecule and this benzene molecule in between that develop interaction. Now this is here non-polar molecule with induced dipole means in benzene molecule the electron density gets distorted, electron density shifted and created here two poles. One is positive and one is that negative. That is the two pole is created in benzene molecule. Okay. So this is the dipole-induced dipole interaction. Now we will study the next fourth one type, London dispersion forces. Now London dispersion forces, these forces are generally show non-polar molecules and the inert gases. They show this particular type of the force of attraction. Now, for example, oxygen, nitrogen, methane gas, helium gas, halogen gas, carbon dioxide, and other also inert gases, they can show the particular the types of attractions. Now, we will see here the example benzenes. For example, benzene has no dipole moment, it has zero dipole moment, and no dipole-dipole interaction is also. Still, benzene it is in liquid state. Is possible, that is in liquid state is present. So its explanation depends upon this the London dispersion forces. म्हणजे याबद्दल असं गृहीत धरलं होतं की मॉलिक्यूल मध्ये जे इंटरॅक्शन असतं अट्रॅक्टिव्ह फोर्स असतं ते केवळ फक्त पोलर मॉलिक्यूल आहे म्हणून किंवा डायपोल मोमेंट व्हॅल्यू आहे म्हणून ते मॉलिक्यूल्स मध्ये ते प्रकारचे मग डायपोल डायपोल इंटरॅक्शन असतात असं गृहीत धरले होते. परंतु नंतर मात्र असं आढळून आले आहे की पोलॅरिटी पोलर मॉलिक्यूल नसेल, डायपोल मोमेंट व्हॅल्यू जरी नसेल, झिरो असेल तरी सुद्धा एक प्रकारचं अट्रॅक्टिव्ह फोर्स त्या ठिकाणी प्रेझेंट असतो आणि तो आहे लंडन डिस्पर्शन फोर्सेस. ओके, सो दिस इज weak force. It is very weak force of attraction. That's why this is also called as van der Waals force of attraction. Van der Waals forces. Okay. Now, how these forces develop? Non-polar molecules, atom and molecules. These are atoms and molecules. In this case, the motion of electron is taken. Do you know that the in atom, central nucleus, and that electron revolving around that nucleus, due to the motion of electrons, the temporary dipole moment is created. Okay, temporary dipole moment is the developed. So that is a momentary dipole moment here momentary dipole produced. That is also called as instantaneous dipole moment value is there. So this momentary dipole of one atom can affect electron distribution in the neighboring atom and induce dipoles in them. Okay, the redistribution of that electrons. So that's why here momentary dipole of one atom can affect that the electron distribution in the neighboring atom. Then here polarizability means ability of another molecule to become polar by redistribution of its electron. Okay. Here polarizability factor also play in this the London dispersion process. That's the ability of another molecule to become polar by redistribution of its electron. So electron density just that is distributed, that is again here the redistribution that is takes place. So the way of that here the London dispersion process. Now here London dispersion process is again here the play important role in boiling point. It can affect the boiling point of that certain substance. For example, the N-pentane having that the boiling point is here, the way of that 309.4 kV, and neopentane is the boiling point is that 282.7 kV. Now this is one structure. N-pentane is straightforward structure, straight line structure. And another structure is the neopentane is the compact. That's why the more spread structure having that more London dispersion forces. Okay. So London dispersion forces also depends upon that the size of molecules. Okay. Molecular mass. Okay. And that the number of electrons present in atom or molecules is also. Now we are going to study this is fifth one type, hydrogen bonding. Okay, this is types of intermolecular forces under this they are given this fifth one. What do you mean by hydrogen bond? So hydrogen bond is nothing but it is the electrostatic force of attraction between the positively charged hydrogen atom of one molecule and the highly electronegative atom of other molecule. So it is called as here the hydrogen bond. It is the electrostatic force of attraction between the positively charged hydrogen atom, polarized hydrogen atom of one molecule and other atom of this molecule is what, like that should be the strong electronegative atom, like that the nitrogen, oxygen, fluorine. Okay. Now intramolecular, they have given this is here the two types, intramolecular hydrogen bond and intermolecular hydrogen bond. Okay. Now intramolecular hydrogen bond is nothing but the hydrogen bond formation within single molecule. Okay. So for example, this is ethylene glycol. Okay. Now look here, this is CH2H. This is the way of that negatively charged oxygen, this formation bond here hydrogen. Okay. So within the molecules hydrogen bond takes place. For example, another is the salicylic acid. Okay. Look here, salicylic acid, this is COOH group and this is OH group. So here again that this oxygen and this is that hydrogen bond formation takes place. Now second one is the intermolecular hydrogen bond. Intermolecular hydrogen bond means what? The hydrogen bond for a same molecule or maybe the different molecular. For example, two molecules of water or the molecules of that water. Okay. So these water molecules, within these water molecules, the way of that hydrogen bond formation. Look here, this HOH. Now this is way of that here hydrogen bond formation. Okay. Now this is the hydrogen bond formation. Now this is another water molecule is the same molecule example. But here another example is what? The hydrogen bond formation between hydrogen fluoride HF and the water molecule. Look here, this is HF, I have written this, and then this is the bond formation between oxygen of that water molecule and hydrogen of that fluorine molecule. Now, due to the hydrogen bonding present in molecules, so affect the boiling point of that the compound. Okay, so boiling point is more in case of liquids molecule containing hydrogen bond. This is in general. Now, in case of hydrides of that, the nitrogen. In case of hydrides of that, again that nitrogen, oxygen, chlorine. Look here, this example: ammonia, NH3, water molecules, and this HF. They are having that generally high boiling point. Why? Reason is what? Due to the presence of hydrogen bond. In this case, hydrogen bonding is present. Therefore, boiling point of these hydrides is generally high. Now, intermolecular forces and thermal energy. The next one is intermolecular forces and thermal energy, how they related with each other. Okay, so as we see the states of matter changes like this: gas convert into liquid and liquid convert into that solids. Do you know that? What happened here? This is intermolecular force of attraction goes on into the gas. In this case, gas is very, but in liquid quite more, and in solid intermolecular force of attraction is more. Intermolecular force of attraction is what? Is intermolecular force of attraction is nothing but it is an attractive force or repulsive force present in that particular molecules. Okay, so the intermolecular forces increases from what? Gas to solid. That time, same time that thermal energy decreases. Okay, so intermolecular force increases, but thermal energy decreases. What is thermal energy? Thermal energy arises due to the kinetic energy of that particles. Okay, and how the kinetic energy arises due to the movement of that particles present in that particular molecule. And we know here in solid that movement of particle is very less, and that's why that the intermolecular force of attraction is more, but thermal energy is here decreased, that is the lower. Okay, so this is